So I want to do a little Houdini test to see if I could set up that first level we were talking about in the temple on top of the mountains. So I want to start with just a pillar, because that seemed an easy place to start. So I created a tube, I capped it, it's a polygon, and right now it's got 12 columns and 10 rows. The height is adjustable. Let's keep it there for now. Now, just a pure pillar is not particularly exciting, so let's try to make it like a Roman pillar with chunks cut out of it. To do that, I'm going to make a cutout. This is, again, just a tube, just slightly smaller, same length. I'm inheriting the length from elsewhere. I'm going to transform it to the side. So we still got our core here. I just want to kind of line up with the edge of the core. And then I want to make a copy. Now, the copy swap is essentially just something that drags and copies the same thing, does a little transform along the way, in this case rotation. So if we have just one, that's kind of sad. Two on the opposite side, 3, 4, 5, we can make as many as we want. This little piece of code here, 360 degrees divided by the number of copies, will keep it balanced. Let's keep it at 10. Okay, now we got our core and we got our cutouts. And what we're going to do is we're going to use a Boolean operation to cut the cutouts out of the core. Yep. So we can still see all the original tubes here. Well, you see how we're kind of cutting out indentations in that. Right, so now we've got a little Roman statue, Roman pillar. And we can apply texture to it, and let's have a look at how that looks. So now we've got a texture map as well. And the texture map means we can do things like light mapping it later on. Currently it's kind of sitting there. So let's shift it up so it's standing on the edge of the screen. On the orgo. Okay. So that's our unbroken pillar. That's our first thing. And we're gonna export that and keep that around, because until we start messing with it, this is the geometry we want. It's still relatively heavy. And we could simplify it if we wanted. It's only 686 polygons though, so I think we're probably okay. Now the next step here is I want to be able to do things to it. Now, so far I could probably done this in Max just as easy or even easier. What I'm about to start doing now is a little bit beyond what Max does. So, the first step is I'm going to create a fracture of this. So first I need the fracture points. You can see the fracture points here. I can control the number of the density of the fractures. So if I wanted a whole bunch of fracture points, I'm also going to get 1 gazillion polygons, so let's not do that. He seems to work. And we're going to create a Verneuil fracture. If you look at the Verneuil fracture here, it's essentially a way of splitting up volume into small chunks along borders that make sense. It creates small chunks, big chunks. Okay, we're done. Let's do a quick vertex wrangle. All I'm trying to do here is I'm trying to divide it into 5 groups. I can make more or less, so that each of these chunks here are kind of self-enclosed. They have a name. The fact that they have a name like this allows me later on to refer to them. For example, if I wanted to cut out just the top 1/5 and explode that without anything else. Save that to the file and drag it out, and that's the broken side. So now we have the actual broken geometry. The last 3 here do nothing at the moment, but eventually they're going to be quite important. This is where we promote this guy to a rigid body object and connect it to the simulator. So that's our pillar. One pillar, however, does not make a particularly exciting simulator. So next step is we're going to need a floor. Let's start with a box. All good floors start with a box. Okay. Now, much like before, I'm going to scatter, so I can shatter this thing, and then I'm going to create a Verneuil fracture of it. Okay. Now, if I just wanted to collapse the whole floor, that would be how I did that. But that's not actually what I had in mind. Instead, what I wanted to do was to remove only part of it. And to do that, I'm going to use a paint node. A paint node essentially allows you to to draw straight on the geometry. In this case, where I'm drawing orange is where we're going to be deleting the elements. Where I'm leaving the purple, we're going to just leave it there. I've been drawing the points though, and I really want to be drawing the full primitives. So let's promote all those point attributes, specifically the to remove property, which is what I was painting, and promote that to all the primitives. So now every primitive has that property. You can see it down here. This is for the various pieces. Here's those that have remove and those that don't. So that's great. And if we drag this one over here, we can see these are the ones we're going to delete. We can also see the problem with this, because the Voronoi fracture has created an upper and a lower bounds, and we don't really want that. So we wrote a little vex script again to kind of move, spread it out like an ink blot. And now if we have a look at that instead, you'll see that both the top and the bottom have been set up for deletion. So let's just delete those, and now we have our basic floor. Now what would be really cool, and we'll try to work that out later on, is if this ink blot of ours, if this thing was more or less semi-random, so that when I create a copy of this, it would randomly create an ink blot to go with it, and that would allow us to create any number of floors, which would be fun. Don't know that yet, so let's just leave what we got for now. Okay. So now let's put it together into a level. Hide that floor. Show that level. Okay, so here's our floor. And here's our pillar. Now what I want to be able to do is I want to have more than one pillar, obviously. So we're again using our little copy guy, if you remember this. So now I've got 2 pillars, 1 pillar, 2 pillar, 3 pillar, 4 pillar, 5 pillar, 6 pillar, 7 pillar, 8 pillar. There we go. Yeah. And I'm going to use this guy here to match the size of the mesh. So the more pillars we got, the bigger the space gets smeared. And we can adjust how much each of those copies are. Right now I'm translating by 4. If I translate by 10, for example, our pillars become much more widely spaced. Let's keep that something like that. Cool. So we got a little angle for the creatures to come at us. We can see the horizon in the distance, and a hole for the elevator to go down. So that's one of our floors. And we can repeat this same thing. For example, if we wanted to make another one, start with a geometry node. We do a merge to bring in the object we got. Get that object from one floor, wherever that was. One level, one floor. Here we go. And then we're gonna do copy stamp again. This time, each time we're actually going to be translating. That was not quite enough. And we can actually get the bounding volume of this object. But let's do that later. Let's put it at 20. So we have now created the 4 floors of broken, or 5 floors of broken geometry that we could pass down. The whole thing at this point is pretty high polygon. We're talking about 2 million vertices, 400,000 or 350,000 polygons. So we want to simplify this eventually, but it provides a good stress test for the engine and see how everything's going. Okay, and that's it.